Welcome to Introduction to Reproducible Data Science. You'll be meeting several co-instructors during this introductory module and throughout the course, but to introduce you to the introduction, I'm Curtis Huttenhauer.
And I'm John Quackenbush. We're faculty members at the Harvard T.H. Chan School of Public Health in the Department of Biostatistics. Today, we're in the basement of Countway Library at Harvard Medical School to film this introductory video.
If you're watching this video, then you're interested in reproducible, data-intensive research of some type, and while many of us come from a biomedical background, we'll gear the course toward the broad audience of data scientists. It's difficult to overstate how much reproducibility matters in any modern scientific field. Not just the ability of one research team to reproduce another's results, but your own ability to reproduce results over time. A big part of science is being self-skeptical, and Murphy's Law suggests that if you can make a subtle mistake somewhere during a complicated data analysis process, you probably will. It'll probably look like a breakthrough, fantastic scientific result, too, until you realize it was just a typo.
Our goal in this course is to help you avoid doing research that can't be reproduced. To do that, we're going to introduce a series of concepts, thought patterns, analysis paradigms, and technical tools that together support data science and reproducible research. That means ensuring that you can trust your own research results, that you can reproduce them themselves, and that you can communicate them to others, including journals, reviewers, funders, and your colleagues.
These concepts are intended to translate to fields throughout the data sciences: physical and life sciences, applied mathematics, statistics, and computing. And hopefully we don't have to work hard to convince you that reproducibility in data science matters. Beyond wanting your own results to be correct and easy to double-check, most publishers and funding agencies now require a series of reproducibility guidelines to be satisfied for acceptable research.
For example, the Nature journals require that manuscripts be submitted with a checklist linking figures to data, statistics to methodology, and data to accessible repositories and originating specimens and the assays that were conducted. The National Institutes of Health has reproducibility guidelines for funding recipients and trainees. These range from how you perform your statistics to how you share your data and the software that you use to do the data analysis. But ultimately, your data and your conclusions are going to influence others. And in health and biomedical research, that may actually include influencing the practice of clinical care. So we want to make sure we do things right, and we want to make sure that our results can be reproduced by ourselves and others.
From the academic side, to ensure reproducibility, it's always useful to put yourself in your future self's shoes. If you were to look back on your work a year from now, would you understand it? Could you do it again, easily? Practically speaking, this is almost exactly what does happen during a manuscript revision, so it's not just a thought experiment. And it's not that far off from what happens when you share your research procedures with others. For your own work to be cited and built upon, they need to be able to easily understand, trace, modify, and rerun what you did. If you've ever picked up someone else's analysis code or tried to use a fussy, fragile piece of research software, think about how frustrated you were. And then make sure that your own methods are never as frustrating for others to use.
There's no silver bullet to assure you can do this, but there are best practices, and those include capturing patterns of thought that can be integrated from end to end throughout a research project. This process involves starting with design, going through data collection, reporting, and ultimately data maintenance. Success requires thought and awareness at each step. You have to continuously ask yourself whether the infrastructure you've built will help alert you to whether or not you have incorrect results and to identify where those may have crept in. Whether you'll be able to easily understand and rerun the analysis in the future, and whether someone else would be able to do that too. And while there are many technical tools that will support all of these tasks, none of these are silver bullets either. Often, they're complicated tools designed to help solve complicated problems. But if you use them in a sophisticated and knowledgeable manner, you'll help assure that your work is reproducible.
So consider this course a survey of best practices. We'd like to make you aware of pitfalls in reproducible data science, some failure and success stories in the past, and tools and design patterns that might help make it all easier. But ultimately, it'll be up to you to create your own environment in which you can easily carry out reproducible research and to encourage and integrate with similar environments for your collaborators and colleagues. Thanks for joining us for the course.
Welcome to the course, and we really hope you get something out of this, that you enjoy the presentations, but most importantly, that you learn key concepts that are going to help assure that your own research is reproducible.